Hello student, hope you are well. Today we are going to study gravitation. In the chapter of gravitation, we will study Newton's universal gravitational law and the factors on which this gravitational force and its properties depends. Okay. And other than gravitational law, we will study here gravitational free intensity, acceleration due to gravity, maximum height attained, and orbital motion, satellite motion that we will study here in this chapter. So let's start Newton's gravitational law. This is a universal law. This force is when 2 point masses m1 and m2 are kept at some separation. This force is always attractive in nature. Among four fundamental forces, this is most weakest force. This is longest ranging force, theoretical range is infinity, and this is medium independent force, and this is always attractive in nature. And magnitude of the force is directly proportional to the product of the masses and inversely proportional to square of distance between them. So we can write F proportional m1 m2 upon r square. By writing proportionality constant, we write F equal to G m1 m2 upon r square. Okay. So this is the formula which we will be using to calculate gravitational force between 2 point masses. In the formula, capital G is a universal constant whose value is 6.67 into 10 power minus 11 Newton meter square upon kilogram square. The dimensional formula is m power minus 1, L power 3 and T power minus 2. The gravitational force is medium independent force. Gravitational force is a action-reaction force. The value of capital G is constant everywhere. Okay, so this is, and this force is always attractive. Now let's see a question. Two spherical balls of mass 10 kg each are placed 100 meter apart. Find the gravitational force of attraction between them. Force equal to 6.67 into 10 power minus 11, 10 into 10 divided by 100 into 100. This 0, 0, 0, 0 will get cancelled. So answer will come 6.67 into 10 power minus 13 Newton. This is the force acting between two balls. This is the answer to the given problem. Two stationary particles of masses m1 and m2 are at distance d apart. A third particle lying on the line joining the particles experiences no resultant gravitational forces. What is the distance of this particle from m1? Dear student, this is m1 and this is m2. Let us assume this is small m. This distance is capital small d. Let us assume this distance is d1 and this is d2 and d1 plus d2 equal to d. Okay. If force is 0, if the small m is in equilibrium, then G m1 m upon d1 square. This is equal to G m2 m upon d minus d1 whole square. Let's start solving capital G, small m, small m. So we will get m1 upon m2 equal to d1 upon d minus d1 whole square. Let's take the LCM. Let's take the under root m1 upon m2. This is equal to d1 upon d minus d1. Make the cross multiplication d root m1 minus d1 root m1 equal to d1 root m2. So d root m1 equal to d1 root m1 plus root m2. So dear student, this d1 equal to d root m1 divided by under root m1 plus under root m2. This is the answer to the given question. This is the distance from m1 where small m will be in equilibrium. Okay. Now let's see another question. Three masses each equal to capital M are placed at the three corners of square of side A. Calculate the force of attraction on unit mass at the fourth corner. Here is unit mass. This is capital M, this is capital M, this is capital M, and this is small m. Gravitational force is attractive. So force on 1 kg due to this m will be in this direction. Force on 1 kg due to this m will be in this direction. And force on 1 kg due to this m will be in this direction. Okay. And how much will be the force? Let's see here. Suppose this is F1, this is F2, and this is F3. Dear student, F1 and F3 will be, F1 and F2 will be same in magnitude. This is equal to Gm upon A square. And what about F3? F3 equal to Gm upon this is A, this is A, this is A root 2. Means Gm upon 2A square. Dear student, the resultant of F1, the final force is F1 plus F2 plus F3. This is the resultant force because force is a vector quantity. If we take the resultant of F1 and F2, this will be F1 root 2. So Gm upon A square root 2 plus Gm upon 2A square. So answer to the question is Gm upon A square root 2 plus 1 upon 2. This is the final answer. Okay. This is the final answer to the question. Okay. A mass capital M is split into two parts, small m and capital M minus small m, which are then separated by a certain distance. What ratio of small m upon capital M will maximize the gravitational force between the parts? Dear student, whenever maxima or minima is to be done, we have to differentiate the thing. Okay. Now let's see. This is small m and this is capital M minus m. These are 2-point masses. Okay. Let us assume they are separated by a distance x. So now gravitational force between them is F equal to Gm into m minus m upon x square. This is G mm minus m square upon x square. Here capital G, capital M and x is constant. To maximize force, we are differentiating df upon dm equal to 0. So what we are getting here? We are getting here Gm minus 2m upon x square equal to 0. After solving this equation, we will get a minus 2m will be equal to 0, means m minus 2m equal to 0 means small m equal to m by 2. So masses will be equal in proportion, okay? So the two masses m by m. This m is what? M by 2. So the answer is 1 by 2. To get maximum gravitational force between the parts, okay? This is the answer. Two particles of equal mass small m move in a circle of radius smaller under the action of their mutual gravitational attraction. Find the speed of each particle. Whenever any particle move in circular path, the centripetal force is required. Thus, here in this case, centripetal force will be obtained by gravitational attraction. So, dear student, let's see here. The two particles are moving in circular path, okay, of radius r. Let us assume their speed is v. So, mv square upon r is centripetal force. This is obtained by gm square upon 2r whole square. So, dear student, mv square upon r equal to gm square upon 4r square. Let's cancel r and r, m and m. So, what is v? v equal to gm upon 4r. This is the answer to the question. Now, in this chapter, we will study gravitational field, gravitational field intensity, gravitational potential, acceleration due to gravity, and gravitational potential energy, okay? And also Kepler's laws. So let's start gravitational field intensity. It is also a vector quantity. What is gravitational field intensity? This is a gravitational force expressed by 1 kg test mass. It is a gravitational force expressed by 1 kg test mass. And since the force is attractive, it is written by letter capital G, it is written by letter capital I. So gravitational field intensity is Gm upon R square. This is magnitude. And direction is what? Direction is along the line joining this 1 kg and this is small m. Okay, direction will be towards. So we can write I vector equal to minus Gm. Like that also we can write. And unit is Newton upon kilogram. It's a vector quantity. So dear student, in the next lecture we will be looking for various cases of gravitational field intensity and acceleration due to gravity. Thank you very much.